Hello everyone, my name is Abhijit Katre and I'm Data Science and Business Analytic Intern at Spark Foundation. So my first task is prediction using supervised machine learning model. So in the task, the objective of this task is to predict the percentage score of a student based on the number of hours he or she studied. So basically in this model we have two variables, the percentage score of a student and the number of study hours. First thing first, we import all the required libraries like NumPy, Pandas, Matplotlib, Seaborn. After that, we read the data and then we describe our data. And after that, we get the shape of our data, which is 25 and 2. 25 implies there are 25 rows and 2 implies there are 22 columns. After that, we describe our data by various functions like data.height, data.column, data.types. And in data.info, we got 25 non-null values, which implies that there is no null values present in the data set, so we don't take care of them. And we also get to know that the R variable is float type and score variable is integer type. After that, we get some statistic about our data like mean, standard deviation, minimum, 25 quartiles, 50 quartiles, 75 quartiles. So here we are plotting the distribution plot between our two variables. We can see that the two variables are getting closer in a particular range. So we can imply that there is no presence of outlier in the data set, which is good for the model because outlier put an detrimental effect on our model. After that, we plot the scatter diagram between the two variables, and here we assign number of hours studied to the x-axis and the percentage score to the y-axis. By seeing or observing the scatter diagram, we can see that there is fairly linear relationship between the two variables, and it can validate by the score of data dot correlation, which comes 0.97, which is approximately 1. This means that there is a positive relationship between these two variables. It means like if the number of hours studied increases, the percentage of the scores also increases. After that, we split our data into training and testing data set. We give around 80% of the data set to the training and 20% of the data set to the testing. And after that, we plot the linear regression of our model. Basically, in the linear regression, what the model does, it finds the line or a slope or the intercept of the line where the maximum point falls. But as we can see that there is no line in which all the point fall. So what model does that, basically it finds the line in which the difference between the predicted and actual values is minimum. In other words, the sum of the difference between the predicted and actual value should be minimum. It does internally. Here we can compare our predicted and actual result. So finally the task predicted the score of the student who studied for 9.25 hours is comes out to be 93.69%, which is fairly good enough. And for this evolution of model, we use some performance metrics like means absolute error or root square, which is 94.54%, which is good for the model.